which is kind of neat, I think. So the next part that we need to tackle is the program should ask the user if they want to continue working with the previous result. So this answer keeps the result from the first calculation, num1, whatever, num2. Now, if the user wants to continue working with that number, as is usual in most calculators, then we want to ask them that question right about now. So we're going to use an input and we're going to say type y to continue calculating with, and then we'll insert the answer from the previous step, and we'll say or type n to start a new calculation. And that way we can get hold of their request. Do they want to restart and type in n1 again? Or do they want to simply just type an operation symbol and a num2 and use the previous answer as num1? Now we need to do something about this input. So let's save it into something called choice. And we can save the choice, which we know is going to be y or n, and we can check the choice. So if choice equals, and we'll check first for y, and then in that case that means they want to continue working with the previous answer, and so what we'll do is we'll set num1 to equal the answer. And what we need now to happen is to get them to get the symbol and the next number and then print all of this out. So something like this. But as you notice, this is kind of repetitive. So what do we do when things start repeating? We write a loop, or we use some sort of programming way to save us from typing out or having lots of repeated code. So we could have a variable called should accumulate, so that we could decide whether or not we should accumulate the answer to the next round of calculations. And while that is true, then we will perform all of this functionality and get to the end here. And if again the answer is y, we set num1 to equal the answer from this step, and then because it's a loop, it's going to go all the way back to the top. So that means that this num1 here can't be inside the while loop, and so we need to take it outside so that it doesn't overwrite this part of the code here. So this part will loop, this part will start at the very beginning when the code starts. So now let's run our code file and see if all the functionality up to this point works as expected. So I'm going to add a 3 to 3, and I'm basically going to keep doing this. So I'm going to type y to keep calculating, and again I'm going to add 3. So now you can see the next stage, they're taking 6, which is the answer from the previous stage, plus the new number that I wanted to add, using the operation that I selected to calculate the new answer. So let's try a different operation. Let's say we've got 9 and I want to divide it by 2. And now I get 4.5, which is kind of nice because I've got floats now. So the next thing we need to tackle is what to happen when the user types n. At the moment, not what we want, because we actually haven't got anything that addresses it. So let's write an else statement, and we know that we've got this variable that controls the while loop. So let's go ahead and set it to false if the user no longer wants to accumulate the answer and continue calculating. Now at this stage, it's probably also a good idea to have some new lines so that it separates what the user was doing before. So this way we get that illusion, like what we see here when we type n, that we restart from the beginning. So once that's done though, what we need to do is to start all the way from up here. So how can we do that? Well, what if we take all of this code and wrap it inside another while loop? Now, while that would work, it might be a little bit confusing. And there's actually a slightly simpler way of doing this. We could create a function called calculator. And this function is going to include all of this code. So I'm going to select all of it and then indent it in one go. Now, what I'm going to do is I'm going to call this function inside itself. And this is something in programming known as recursion. So if you solved this project using another while loop, that is perfectly acceptable and it's a perfectly good answer. But while we're here, another wild joke, I want to show you how you can also use recursion. So we've got this function called calculator, which we obviously need to call outside the function so that it runs after the program starts. And then at this line, it sees it and then it goes into the definition and starts running all of these lines of code. But once it gets to here in the else statement, we're going to call calculator again. And what that's going to do is it's going to go to the very beginning of the calculator and try to run all of this code. And it will continue recursion until the user decides to choose something else. So let's try out this functionality, our upgraded calculator. Let's try 4 multiplied by 5 equals 20. Let's type n so that we start a new calculation. We've got all the space added between the previous calculation to appear as if we're starting from the beginning. And then we'll try and do a different calculation. What's 3 divided by 2? And now we could type y to continue working with that 1.5, or we could type n to start a new number. The only final thing we need to do is just to add the logo so that when the calculator restarts up here, we actually see the logo. So let's first do our import right at the top, and the file is, as always, called art. And once we've got that, we're going to make the print statement for the art.logo the first thing that happens in our calculator program. So let's do a final rerun, and you can see we've got our calculator with our nice little logo, and then we got our calculation abilities. We can either accumulate to continue working with the previous numbers, or we can simply type no to start calculating with a brand new number. So there you have it.